All right, welcome back. We're going to do carbohydrates here in a second. I just want to make sure that you should have your reading guides. I'll be going through some of these, specifically probably 3 through 5. And then also I'll go through this first one. So what you should do is in this box, either type lipid or write in lipid, or not lipid, sorry, carbohydrate. And I'll go through these other 4 parts. All right, so first macromolecule we're going to go through is a carbohydrate. So here we go. So carbohydrates, the chief function. So if you want to write that far right side and that table, this is to provide energy for cells and to also store energy. So it's all about fuel. We do have some carbohydrates that serve as structural things, and that would be your starch and so your cellulose, and we'll also go into chitin. But carbohydrates have a building block, so their monomer are sugars, so also known as a monosaccharide. One thing that I would like you to do in the elements table, a part of your table, is include this third bullet point here. Is they use the elements carbon, hydrogen, and oxygen. That's it, and they are found in this ratio. So make sure you include both the elements, and I would also include that ratio. So 1 carbon to 2 hydrogen to 1 oxygen. Let me give you an example of that. If we look at glucose, we have C6H12O6, and fits that ratio. So that's a little bit on carbohydrates. I'll continue on here. Oops. Here we go. All right, so sugars are monosaccharides. Again, monosaccharide is the monomer of a carbohydrate. So if you want to write that down in the monomer, and I can give you an example, is glucose. Glucose is an example of a monosaccharide, also known as simple sugars. These are what us as people, in other organisms, we use it as fuel. They can be converted into other organic molecules such as fats. And they can be combined into polymers like starches and cellulose and chitin, things like that. So, examples of monosaccharides. Glucose, galactose is another example. Ribose is another example, and fructose. So just some good examples. You don't have to include all of those, but maybe include a couple. Glucose is an important one. Glucose is, again, very important one. Sorry about the formatting here. So monosaccharides, they could be linear. They can also form rings. Glucose, for example, is a ring structure. Disaccharide would be 2 monosaccharides put together. So if we had glucose, it would maybe look like this bonded to this. Okay, and that would be 2 ring structures bonded together. Now, what is that bond? It is called a glycosidic linkage. Pretty sure that's in your reading guide. So the bond between 2 monosaccharides would be called a glycosidic linkage. All right, and this just kind of shows how that glycosidic linkage works. This is actually a really good example of dehydration synthesis that you're seeing here. Here again, these are parts of that water. So we're taking water out, building that water. What are we doing? We're to build, right? Taking water out to build. Here's that glycosidic linkage that we built, and the same thing below. So what we have here is glucose plus glucose equals maltose. And here we have glucose plus fructose equals sucrose. Sucrose is actually the sugar that is table sugar. So when you put some sugar in cooking or whatever that you have in your kitchen, that would be sucrose. But that's a really good example there of dehydration synthesis. All right. Continuing on. A polysaccharide is just the polymer. Okay, so when we put a bunch of monosaccharides together, we would build what we would call a polysaccharide. Poly meaning many. It's just the polymer uh, of basically a polysaccharide would be a carbohydrate. Okay? The polymers of sugars. They can serve a lot of roles. We'll go through some examples here and also their function. So starch is a polymer consisting entirely of glucose. This is the major storage form of glucose in a plant. So plants use starch for storing their energy. So I would write this in the example. I would write that starch is energy storage in plants. Glycogen, on the other hand, this is how we as animals store our glucose. Again, what are you seeing here down? If I went back to the starch, you could see this as well. What are you seeing? You're seeing a whole bunch of ring structures, ring sugars bonded together. They look really small here, but that's what it is. A bunch of glucoses put together. And if I would go to the next one for glycogen, again, what are you seeing? You're seeing a whole bunch of those little ring structures, those little monomers, monosaccharides, being linked together. Okay, so this is energy storage in animals. Glycogen is energy storage by animals. This would be found in like your liver. All right, we also can have cellulose. I would write that down as an example. This is a structural carbohydrate, so a little bit different function in this case. Cellulose is found in the cell walls of plants. I'm going to skip ahead to here. That cell wall in a plant, because plants don't have bones, they need to have some structure. Okay, so that cellulose in the plant's cell walls, here again, you see those ring structures all bonded together. You can see they make cross bridges and stuff like that to make that structural component. So this is structural component of a plant's cell wall. And this is actually one of those, if you've ever maybe gone on what we would call changing your diet, maybe you've tried eating a lot of salad and you think, well, I should lose some weight. Well, you'd be right. And part of the reason for that is cellulose is really hard for us to digest. So because we don't digest it very well, we're not getting a whole lot of energy out of that. On the other hand, cows have a specialized four-chambered stomach to break down that cellulose because it is so difficult. They've made adaptations to be able to digest it, whereas we don't have those adaptations. The other structural carbohydrate is called chitin, and where we find this is in the exoskeletons of insects. When you step on a bug, you might notice that crunch. That crunch is actually the chitin exoskeleton. It's really strong. So this would be another example of a structural carbohydrate. So now, before we go on to lipids, I just want to make sure you've covered everything. So if we look at monomers in carbohydrates, you should have said like a monosaccharide. Think of like a simple sugar. A good example is glucose. For the elements section, you should have carbon, oxygen, and hydrogen in that classic 1 carbon to 2 hydrogen to 1 oxygen ratio. Just some examples. Sucrose was table sugar, I mentioned. Starch was energy storage in plants. Glycogen was energy storage by animals. We talked about cellulose as far as plant cell walls. It's a structural carbohydrate. Chitin was another one. Again, if you don't have every single one of those, not a huge deal, but you should have at least a few. And then that function, their chief function is to provide energy, and you could also mention they do have some structural components. So that is carbohydrates.